All right, IBAASL2. Today we're going to talk more integrals, backwards derivatives, antiderivatives, but today we're going to spice it up a little bit with sort of a backwards chain rule. So the first thing I want to do is show you guys, like, if you didn't really know about the chain rule, if you just tried to apply what we've already learned about integrals to this right here. So we've been saying that this would be 1 over 4 plus 1, and then this would be 2x plus 3 to the power of 4 plus 1 plus c. So this will give us 1/5 2x plus 3 to the power of 5 plus c. Now, if this were true, if this rule works, we should be able to take the derivative of this and get the original function. So what I want to do is take the derivative of that. So I'm going to check it by doing dx, which means just taking the derivative of 1/5 2x plus 3 to the power of 5 plus c. Now the plus c part, when we take the derivative of it, will just go away. So we really just have to focus on the derivative of this right here. That's a chain rule, which says you take the derivative of the outside with the inside untouched, and then times the derivative of the inside. So derivative of the outside would be taking the 5 out front and then dropping it down by 1. So we'll get 1/5 times 5 times 2x plus 3, and then 5 minus 1 is 4. And then we have to do times the derivative of the inside, so we get 2. Now these cancel each other out, and then we get 2 times 2x plus 3 to the power of 4. Now, you guys, if we look at this right here and then check it with the original, they don't quite match up. That 2 out in front is a problem. It's not the same as, there's no 2 up here in the original one. So you can still do this process right here, but we need one extra little step to be able to cancel out that 2 in front. Here's that extra little step. You do things as normal, but you got to put a 1 over a in front. Notice that a is the coefficient in front of the x inside, like the linear inside function. So you're still taking derivatives the same way with, like, you know, putting 1 over the power plus 1 in front of it and then dropping or adding 1 onto the power. But you got to do this 1 over a piece. So if it looks like this, you can do that process I just said, or the process I did in that problem above, but then you got to put an a in the denominator, a 1 over a. Really, I should be highlighting this whole thing, that it's like, here's your 1 over a. Because a 1 over a will cancel out the a that was supposed to come out in front when you do your derivative, when you do like times the derivative on the inside. If you do it with something that's e to the ax plus b, you still just take the derivative of, or sorry, the antiderivative, the integral of e to the ax plus b, but then you got to hit it with a 1 over a in front. See, it's the same thing as up here. 1 over a, 1 over a. Down here, if you have derivative of 1 over a linear, remember that that's a natural log when you go backwards when you do your integral. But once again, you got to put that 1 over a in front. Let's do some problems. So we're going to take the derivative of this. Sorry, I really got to change my language. We're going to integrate this. We're going to find the antiderivative. So I do 1 over 6 plus 1, but then I'm going to have to do a times 4 to cancel out the 4 that would need to come out from the inside. The inside will stay the same, 4x to the 5, and then this will be 6 plus 1 plus c. So I think that's what? 6 plus 1 is 7, times 4 is 28. So we get 1 over 28 times 4x minus 5 to the 7th plus c. And we're good. Now, this problem, this is a natural log when you integrate. But it's like this is the inside function down here, so we're going to need to blast it with a 1/3 out in front. So this will be 1/3 natural log absolute value 3x plus 2, close that absolute value, plus c. That one's good to go. You're done. This problem is just an e to the x. The 2 is just going to hang out in front, but this 5 out here, when you do times the derivative of the inside, means that we need to put a 1/5 on the outside. So this will be 1/5 times 2e to the 5x minus 1 plus c, which can be rewritten, equals on all these, as 2/5 e to the 5x minus 1 plus c. Upon first inspection, this might look like a natural log with a chain rule involved, but I think it's easier if you just move it upstairs. Like, don't do integrate yet, but just make this 5x plus 2 to the negative 4 dx. So then we'll need to multiply by 1/5 times 1 over negative 4 plus 1, 5x plus 2 to the negative 4. It's a negative. Kind of didn't really fix it. Let's get it right this time. Negative 4 plus 1 plus c. So let's see. That's negative 3. I think this is negative 1/15 times 5x plus 2 to the negative 3rd plus c. Let's see if the book actually puts that back in the denominator. Oh, they do. Okay, so they resolved their negative exponent by putting this in the denominator. So this problem will be negative 1 all over 15 5x plus 2 to the 3rd power plus c. That's that. You're done. Now, you guys, we're in chapter 10 right now, but we're going to need to jump back and forth a little between chapter 10 and chapter 13. Because chapter 13 was all about doing trig and doing like derivatives with trig. We did derivatives with trig in chapter 13, but we did not finish chapter 13. So 13 continues and does some integration stuff with trigonometry. So I thought I'd start by just showing us some reminders that if you take the derivative of sine, that's cosine. So if you're going to go backwards, the derivative or the integral of cosine is sine x plus c. If you take the derivative of cosine x, it's negative sine x. That was from last semester. Now if you take the integral of just regular sine x, notice there's no sine negative in front of it. Like if it was the integral of negative sine x, the integral would be cosine. But since there's no negative in there, you have to put a negative on the cosine x plus c. So those are the integrals of sine and cosine. Here's some problems. The first one's pretty straight up, that this 2 can just come out and hang out in front, and really we just have to find the integral of cosine x. So this becomes 2, and then the integral of cosine is sine, so we do 2 sine x plus c. And that one's done. Now here, I see that there's like an inside function. That inside function means that it's like a backwards chain rule, and we're going to have to put a 1/3 on the outside to cancel out the 3 that would come out when you do the derivative, is how I think of it. I just said the integral of sine is negative cosine, so this would be negative cosine 3x minus 5 plus c. Always get that plus c in there every single time. The last problem, 4 cosine 4x. Once again, there's an inside function, so you got to do a little backwards chain rule and put a 1/4 on the outside. Then this 4 will just hang out, and then the derivative of cosine is sine 4x plus c. Then you can clean this up a little bit, and the 1/4 times 4 just becomes 1. So our answer is sine 4x plus c. If you were taking a test or a quiz or something or doing your homework and you're like, I'm not sure if I got the right answer, take this and take the derivative of it to check and make sure you would get this, which I think you do when you do a chain rule. Derivative of the outside with the inside untouched times the derivative of the inside. And then, of course, there could have been a plus c on the end. All right, you guys. Happy trigonometrying.